P, Q, R, and S are respectively the midpoints of the sides of quadrilateral ABCD in which AC is equal to BD and AC is perpendicular to BD. So what are we looking at? I'll just draw a rough diagram because it will help us understand and proceed forward. So AC and BD, we can conclude that they are perpendicular. They are equal and they are diagonals basically. That's what I mean to tell. So AC and BD are your diagonals and they are perpendicular. Okay, so we have the diagonals to be of equal length and they are perpendicular. So what is that we are looking at? So we are looking at two lengths which are equal and perpendicular. So the condition is that they should be equal and perpendicular. That's all. Are they going to be passing through the midpoints? Need not be. It can be something like this also. Some random thing. So please understand that this lengths are equal and they are perpendicular does not mean they are going to pass through the center. It's a tendency to draw that, but you have to be specific. You have to satisfy the specificity in the question and nothing else. Something like this. It does not need to be a kite or a square or anything. Yes, the condition can satisfy those two. Oh no, kite it does not satisfy. Actually, this condition satisfies in square, but additionally, the square diagonals bisect each other. Okay? In a square, we have the diagonals to be equal, but they bisect each other. That is the point, say O over here. Right? It's the midpoint here. It need not be. Okay? So please read the question again and check if you have done it right. Okay, next is I need to complete the diagram first thing. So let's do this. That is those are your midpoints. So they are asking us to prove that it's a square. So yeah, my diagram is not exact. Maybe the length, this dB length is a bit too long. If I had made it short, then this would have looked like a square, But this is PQRS, that is still there. And we have the opposite sides and all the sides to be equal, parallel, opposite side to be parallel and the angles to be perpendicular. This is the whole funda. Okay, so now the complete diagram is completed. So you can pause and have a look at what is that we are doing. Okay, I hope you guys read and verified that diagram is correct. So by default, we know that these two will be parallel. Why? Midpoint theorem. Again, we are looking at proving something to be a square. So all these conditions has to be satisfied. So how will we do that is something that we have to be smart about. So proving that opposite sides are perpendicular is quite simple. Midpoint theorem. And after that, proving that the adjacent sides are equal, that we have to make use of midpoint theorem again by calling your base sides as 2a and all of that. If you didn't understand what I'm talking about, I'll be writing and explaining to you guys. First thing first, I'll write AC being equal to BD, and then I'll let the length AC be equal to 2A, therefore BD will be equal to 2A. Okay. Next, AC is perpendicular to BD. So along with this, we'll consider let O be the point of intersection. That point we will use point of intersection of AC comma BD. Anything else? Yeah, we have been given that P, Q, R and S are the midpoints. Of sides AB, BC, CD and DA respectively. And now to prove, so what is that we are trying to prove? To prove PQRS is a square. So they have given what is the end answer, how the end answer should look like. We just have to derive it out, write it off. That's it. So math is very simple when they give what is that we need to talk about. Right? You have the answer in front of you basically. First thing first, we'll consider one of the triangles and tell that the base and the right. I hope you guys know this. We have done this kind of question in your basic exercise question and extra set of questions also. So what is that we are looking at? We are looking at triangle ADB as S and P are the midpoints of AD and AB. This implies SP is parallel to DB, right? This is as per, yes, midpoint theorem. So we also can tell that SP is half of DB. Therefore, SP is half of DB and DB is 2A, so this will be A. So we just prove that this length is A, this length will also be A, and this length will be A, and this length will be A. So as and when we write, you will see that, and that's what we need to conclude. So for that, we'll tell similarly from triangle. So let me copy this off. No point in going back and forth. Okay, let that be there. Similarly from triangle, we have DBC. We have RQ being parallel to DB, and RQ is equal to half of DB. So this will be equal to A. I guess. So quite a few set of things can be written in this way. So we can also tell similarly from triangle, other set of triangle being ADC. ADC, what do we have? We have SR being parallel to AC and SR is equal to AC by 2. So this is also equal to 2. Sorry, it's equal to A. Then we have similarly from triangle ABC. Okay. Since we have written all of that, see these are the midpoints and all of that. So we can directly conclude this. So we have PQ being parallel to AC and PQ being equal to AC by 2. So that's equal to A. So from all of this, what can we conclude? All the sides are equal and opposite sides are parallel. But we need to do one more thing. What is that? Yes, we need to talk about one of the angle at least being equal to 90 degree. Is it not? So let me call this as M or something. And let me write this. Okay. Again, we just have to prove one of the angles is 90 degree and we are done. We just prove that the following structure is what we have the sides to be equal and parallel. So it can be either a kite or rhombus or a square. To prove that this is a square, we have to prove that the angle is equal to 90 degree. Okay. And that's what we are trying to do. So for that, I'm considering angle AOB plus M is equal to 180 degree because they are co-interior angles. So M is equal to 90 degree, and then tell M and angle S are what? Corresponding angles, and we are done. Okay, yes. Right? So we have consider or not consider angle M plus angle AOB is equal to 180 degree because SP is parallel to DB. I have the diagram in front of me, so I'm able to do this, right? And these two are, yes, co-interior angles and co-interior angles. Okay, so we have this set of things, and therefore angle M is equal to 90 degree, right? And we have angle RSP is equal to angle M. All of them are equal to 90 degree, as SR is parallel to AC, and they are corresponding angles. Right? And yeah. So we have just proved that one of the angle is equal to 90 degree. So from quite a few things, starting from equation 1, equation 2, then we have 3 and 4, actually including this, from all of them, what can we tell? We have all the sides to be equal and one of the angle to be 90 degree. So what can we imply? So from 1, 2, 3, 4, and yeah, we'll call this as 5, not this, and 5, can we tell? This implies PQRS, I guess. Yeah, PQRS is a square, as all sides are equal, and one of the angle is 90 degree. And parallel, comma, one of the angle is 90 degree. Okay, that's it. The line of thinking is very simple. All you need is a good diagram, understand the question exactly, and draw the diagram. That's the very first thing. After that, it's basically knowing this and midpoint theorem for this chapter. So pretty much geometry questions are similar to this. 90% of the question you guys can answer this way, right? 10% is there which is a bit tough. So here and there you guys have to struggle a bit. That's it.